Hi everyone, welcome back. In this video, I will walk you through how we can fine-tune a biomedical language model called BioBERT for named entity recognition. We will use the BC5 CDR dataset, which contains biomedical text annotated with chemicals and diseases. To make the training lightweight and efficient, we will add LoRa adapters on top of BioBERT and then test the model on some clinical text to extract structured information. The dataset is widely used for biomedical entity recognition tasks. It contains sentences annotated with two main types, chemical and diseases. We use the standard BIO tagging scheme, which means tokens are labeled as beginning of a chemical, inside a chemical, beginning of a disease, inside a disease, or simply outside if they don't belong to any entity. This gives us 5 labels in total, as you can see on the screen. When we tokenize our text with BioBERT, words can break into multiple subwords tokens. This creates a challenge because each word has only one label, but now it's split. To fix this, we align labels so that the first subword keeps the original label and all other subwords gets the appropriate I tag. This alignment is critical for training a reliable NER model. Now, instead of fine-tuning the entire BioBERT model, which has over 100 billion parameters, we used LoRa adapters from the PEFT library. LoRa inserts small trainable layers into the model, allowing us to adapt BioBERT to our datasets while keeping most of the base model frozen. This also makes training much faster, requires less memory, and still give excellent performance. For training, we use Hugging Face Trainer API. We train for 5 epochs with a batch size of 16 and we evaluate using the SeqEval library. The evaluation gives us precision, recall, F1 score, and accuracy. During training, we can see these matrices improve with each epoch, showing that the model is learning to correctly identify chemicals and diseases in text. After training, we save both the tokenizer and the LoRa adapter. This means we don't need to retrain the whole model every time. We can just reload BioBERT, attach the LoRa adapter, and start making predictions. This is especially useful if you want to share the trained model with others or deploy it into production. When we run the model on new clinical text, it outputs tokens with their predicted labels. But because of subword splitting, we add a post-processing step to merge subwords back into complete words. Once entities are merged, we can easily extract structured information. We build a table with columns like input, text, chemicals, and diseases. This transforms messy unstructured clinical notes into a clean structured data. So yes, in just few steps, we fine-tune BioBERT with LoRa for biomedical named entity recognition. We trained efficiently, aligned labels correctly, saved and reloaded the adapter, and finally built a practical pipeline that turns free text into structured information. This is really powerful for use cases like clinical research, drug safety monitoring, or analyzing electronic health records. Thanks for watching.